Alright, so welcome to the Gate Academy English channel. My name is Umashankar Tripathi, my dear. So, I would first like to welcome you all on the Gate Academy channel, my dear. So, in this, we are going to have a live quiz session of fluid mechanics. Okay, right, my dear. So, we are going to have a live quiz session of fluid mechanics. Okay, in this, so please, if you have not yet liked and subscribed the channel, please do it because we are coming with so many good videos, so many quizzes, so many educational things in this channel, right? Okay, so my name is Umashankar Tripathi, and today I am going to conduct the fluid mechanics quiz. Okay, so a little bit about me. So I am a research scholar, a PhD scholar from Indian Institute of Technology, Roorkee, and I am having a teaching experience of last 9 years. Okay, and from the last 9 years, I am into this field. Okay, so madam, this is the first quiz of fluid mechanics. We are going to have further 4 more quiz sessions on YouTube only. Okay, so let's start with this. Okay, so first of all, I would like you to join this quiz. So you can see a link provided on the top of the screen. Go to bit.ly hash TGA020E. So first of all, beta, please log in into it. And there you have to register yourself. So how we are going to give this quiz, how we are going to give this quiz. So if there is a doubt, you can ask me in the YouTube chat box. Okay, so first of all, you have to go on this link and you have to register yourself. So I would like to request you to write your real name in this. Okay, I would like to request you to write your real name in this. So please join, my dear. Please share it with your friends also. See, more the students, more will be the fun, right? So what is the purpose of this quiz, my dear? So in this quiz sessions, we are here with some questions, okay? And you need to answer them and you need to answer them correctly. So sir, this is the quiz with timer. So what does that mean? So we have to answer in a given time. So till now only one student have joined. Please join, more students join. Okay. So how to play this? First of all, you have to register yourself. Okay, please go and register yourself. Okay. So if you are having any other device, like if you are having a laptop, if you are having a mobile, so if you are seeing me on the mobile, you can join this on the laptop, or if you are seeing me on the laptop, you can join me on the mobile. And if you have only one device with you, so if you have only a laptop, what you can do, you can open 2 windows and there you can join. Okay. If you do not have the laptop, sir, I have mobile only one mobile. So you can use a split screen function, mostly available in the Android phones. Okay. So in this split screen function, you can join. Okay. And also you can see me. Hello, Praveen. Hello. I hope you joined the session. Okay, so please, all of you, I request all of you again, please go to this link and join and register yourself with your own name. It's just a matter of 1 minute. See, it is going to be a lot of fun there. Okay, so what else? So there will be no negative points. We'll be going to see 5 questions. Okay, one by one, along with the timer. So every question will carry some points. Okay, every question will carry some points. Okay, and it will be shown to you at what points. So tougher the question, obviously more will be the points, and sooner you answer, more marks you will get, more points you will get. Okay, so basically what is going to have we are going to have in here. So basically you have to answer the question and you have to answer it quickly in order to attain more points. Okay. Okay, so what is the use of it? Like in gate examination, we very well know that's or not only in gate, in any examination, we have to answer. We have to answer the question correctly. Also, we must try to answer it as quickly as we can. Right, my dear? So I hope all of you have joined. I can see some students have already joined, but few of you have not joined yet. So please, I request all of you to join it as early as you can. And without wasting any time, let's start with it. Let's start with it. So let's start the quiz, my dear. Let's start the quiz. Okay. So here you go. First question. It is a MCQ question. So you can see the time on your screen. So if you are having open this platform, so you could see this question on your screen. So this is a MCQ type question, that is multi-choice question, multiple choice question. So in this only one option is correct. So you have to solve it quickly. So those who are joining now, please you can join the quiz on the link given there at the top of it. Please go there, register yourself, and registering doesn't mean that it is a long process. You just have to write your name. So please write your real name, my dear. Please write your real name, and let us see how much we understand this fluid mechanics subject. All the questions we have framed here are of gate level. Okay? So we have to answer in this time frame. Please go ahead. Please do it quickly. Very simple question. Very simple question. I can see none of you have answered yet. Very simple question. Properties of fluid. Very first chapter question. These kind of questions are getting asked in gate examination in 1 marks or sometimes 2 marks. Are go for it. Only 1 minute is left. None of you have answered me yet. So what we are going to do, we are going to see questions one by one. Okay. So that we feel it's like a test or something. And after we complete all the questions, we can discuss the solutions, right? We can discuss the solutions. So I have got one answer. Please, rest of the students, please answer. Please answer. What do you feel? Please answer it. Please answer it. Please go for it. Okay, so I have got 3 answers. Still some students have not answered. Very simple question. Okay, let me give you a hint. It is a Newton law of viscosity question. It is a Newton law of viscosity question. Please go ahead. We see these kind of questions a lot during our preparation, and in also gate examination. If you have solved the previous year question, definitely you must have gone through these kind of a question. Are only 15 seconds. Still some of you have not answered. Don't do that. Please go for it. Very simple question. Still some of you have not answered. 3, 2, 1, and times is up. Okay, so what is the correct answer? The correct answer is 0.2. So all 3 of you who have answered this question have answered it correctly. Now let's see who have answered correctly. So Harsha have answered it. Harsha has answered it in the most quick time, right? Right. So he has got 68 points, right, my dear? He has got 68 points. Okay, now going for the next question. Please answer this. So this is a MSQ question, multi-select question. Okay, so in this more than one options are correct. So we know in 2021, we know in 2021 we have this new questions addition. Right? We have this new questions type of questions added in the syllabus, like MSQ, multi-select question. Right? In this, more than one answer is correct. Okay, so you can select more than one options here. So whatever answers you feel right, you can select. So the time for this question is just 2 minutes, because this is a theoretical type question. No calculation is required. So we can answer it quickly. Please go ahead. Please go ahead. So I can see only one answer till now. 44 seconds is left. Please go for it. Please go for it. Please go for it. So everyone has answered. Oh my God. So the correct answer for this question was A and B. A and B. So let's see how many of you have given it the right answer. Okay, so none of you was able to answer it correctly. Right, my dear? Okay, so still Harsha is leading the chart, but all of you have not given, any of you have not given answer correctly. Satvik, you can join this by the link given in the box in this. So now this is the third question. So this is a numerical ability question. This is a numerical ability question. Okay. So in this we have 3 minutes. So you can answer. You can answer it in numerical data. You can put a value. So we know in GATE examination we have MCQ questions, MSQ question, NAT questions. Right, my dear? Right, my dear? Okay. 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 So we can quickly answer this question. Very simple question. It is a question of manometer, pressure measurement. So we know that we can measure the pressure in a pipe by using a manometer, right? Okay. So last question, none of you were able to answer correctly. It was a very simple question. I don't know why you were not able to answer correctly. Now I'm expecting an answer in it. It must not take more than 3 minutes. See, in the examination, my dear, we require to do the question in time. Okay? We are required to do the question in time. Right? Right? We have to give the correct answer, and also we have to give the answer. We have to give answer in the prescribed time. Please go for it. Very simple question. So these kind of questions are getting asked in 2 marks. So only one answer till now. Please go ahead. It's a numerical ability question. Please go ahead. Please go ahead. Please go ahead. We all can do it. We do these kind of questions a lot in fluid mechanics. Right or wrong? Please go for it. 50 seconds. 3 answers I have got till now. Still few of you have not answered yet. Please go ahead. Please do it. Please do it. Please do it. "28 seconds. It's a simple manometer problem. It's a simple manometer problem. It is a YouTube manometer. We need to pipe the pressure inside A. Just by using hydrostatic law and basic concepts of manometer, we can do. Please go ahead. Please go ahead. Please go ahead. Okay, everyone has answered. Now let's see the leaderboard. Okay, Keshav. Very nice. So only Keshav was able to give the answer correctly. Only Keshav was able to give the answer correctly, and now the points of Keshav has increased to 99. Okay. Now let's quickly move to the third question. So the second question, none of you was able to answer. In the third question, only one was able to answer. So if still somebody want to join, can join. So again, it is a manometer question. It is a bit tricky one. No calculation mostly required in this question. But I have given 3 marks. I have given 3 marks for this question. Sorry, I have given 3 minutes for this question. Please go ahead. Please read the question properly. It's a bit tricky question. Right? It is a bit tricky question. Please go for it. Please go for it. Without wasting any time, we are just moving from question to question. And in the last, when we solve all the questions, we can discuss that. Right, my dear? We can discuss that. Right? We can discuss that. All right? 2 minutes remaining. See, very simple question. Okay, 2 of you have answered. Right, 2 of you have answered. Please, rest of you also answer. So those who are coming live just now can join on the link you see. Link is also mentioned in the chat box of YouTube. You can join it from there also. Right, please answer so I can see some more students are joining in. Please go for it. Please go for it. Please go for it. So, my dear, remember this is the first quiz. Okay, so everyone has answered. Now, let us see how many of you have answered correctly. So, 5 of you have answered correctly this question. Very nice. So, now Keshav again is leading the chart. So, all 5 of you have answered it correctly. Very nice. Very nice. All 5 of you have answered it correctly. Chalo, let's move to the last question now. Let's move to the last question now. Okay. Okay, so this is the last question. Very simple. Numerical ability question, numerical data question. Right? So you have to write your answer, whatever you are getting. So it is a question of chapter hydrostatic forces. This is a hint. Now let's see how many of you can do it. Please go ahead. This is the last question for this quiz. And after this question, we are going to having discuss all these questions. Okay. Okay. So very good. Last question. You were able to give the right answer to it. Okay. One of you have answered it. Very nice. Very nice. Very nice. One minute, 30 seconds remaining. Please go for it. It is a very simple question of hydrostatic law. So we are going to have the next quiz day after tomorrow also. Okay, we are going to have, so this was the first quiz. Okay, the purpose of it, so give you, so by doing this, we will have a brief revision also of the important concept and we can come to understand it where we stand. So I would like to request you to share this to as many as students as possible so that all of them can have the benefit of it. Okay, still some students are remaining to answer it. Still some are remaining to answer. Can we please answer it correctly? Can we go for it? Can we do it correctly? Please go for it. Please go for it. Please go for it. $20. Still some of you are remaining. The time for this question was more than sufficient. Please go for it. Okay, so the time is up. All right, so none of you have given the correct answer to this question. Okay, so Keshav has won. Very nice. Although you are not able to answer, any of you are not able to answer this question correctly, but Keshav, wonderful. Claps for you, my dear. So you have won this quiz session and you are topping the chart. Okay, so you have answered, I think out of 5, you have answered 3 questions correctly. Okay, so Keshav, congratulations to you, my dear. Okay, but still there is a scope of improvement, and the rest of you who are unable to do, to do some of the questions correctly. So, my dear, I am expecting that in the next quiz session we will improve. Acha, Keshav Balaji. Okay, very good. Oh my God. Okay, so now we can have these questions discussed. Okay, we can have this question discussed. So I am hoping improvement in the next quiz. We have 4 quizzes left with us, so in the next quizzes we can have the improvement also. Okay, now in the first question, what was the first question? Let us now briefly discuss these questions. Okay, so when a flat plate, so most of you have given the correct answer to this. So when a flat plate of area 0.2 meter square is pulled at a constant velocity of 20 centimeter per second, related to another parallel stationary plate located at a distance of 0.02 centimeter, if the fluid between the plates have a dynamic viscosity of 0.01 poise, the force required is, right? So basically, it is a question of Newton law of viscosity. So we have to find force. So from the Newton law of viscosity, we can find the shear stress, and when we multiply the stress with area, we'll get the force. So shear stress is what? Mu du by dy into A. Now, what is this mu with us? It is given to be 0.01 poise. Do not forget to convert the unit. So, to convert the poise into SI unit, so it should be 10 to the power minus 1. Now, what is the velocity? It is given to be 20. So, du means some velocity, right? Difference of velocity. So, if we consider one is 0 or relative velocity is given, you can take it directly divided by the distance, that is 0.02, multiply with the area, that is 0.2. So if you calculate it, I am expecting we are getting 0.2. Do we or don't we? Are we getting 0.2 or not? Are we getting 0.2 or not? Yes, sir, we are getting this 0.2 Newton. So the answer to the first one is 0.2. Any doubt in this question? Do we have a doubt in this question? Please answer me. Now, moving to the next question, I don't know why none of you were able to answer it correctly. Okay, so now it is a question of capillary rise, Karshan. Okay, it is a question of capillary rise and fall. Now, do we understand this? That what we know that capillary rise or fall is proportional to 1 by d. Is it or isn't it? What is the formula of capillary rise or fall? Now, formula for capillary rise and fall both are same, right? 4 sigma cos theta upon rho GD. Yes or no? So basically what we can say is that H is proportional to 1 by D. So what does that mean? So it means that lower the diameter, higher will be the capillary rise or fall, because formula is same. So definitely we have two glass tube of diameter 2 mm and 4 mm. Diameter 2 mm and 4 mm. Now lower the diameter, higher will be the capillary movement, whether it is fall or it is rise, because the formula is same for fall and rise. So what is the correct option? A and B both are correct. Now, any doubt in this? Please answer me. Why we were not able to answer it correctly? Why we were not able to answer it correctly? Please answer me. Do we know that the dia, more the dia, lower will be the capillary change? So we learned this, that manometers are mostly made of the tubes having diameter more than 6 mm, right? Why is it so? To avoid the capillary movement of fluid inside the tube, right? Right. So definitely the lower the diameter, more will be the capillary change. So is there any doubt in this? You can ask me. None of you have given the correct answer to this one. Can you answer? Can you say something? Wonderful. Okay, so I am expecting no doubt in this. Now moving to the next part. So find the absolute pressure of A. Find the absolute pressure of A in the pipe in kilopascal connected to manometer as shown in the figure. Consider G is equal to 10 meter per second and atmospheric pressure is 100 pascal. Okay. So how can we do it? So let's suppose this point is A. So what is the simple way to solve a manometer problem? What is the simplest way to solve a manometer problem? So what we can do, we can firstly change everything to water. Now changing everything to water, we can say HAW. So let's consider the pressure in this pipe as HAW. Now moving in this direction, we know when we move horizontally in a fluid, no change of pressure is there. Now moving downwards, we can add. So what is to be added? That is point A into 0.05, right? Right, converting to water something, we can do H into S simply by multiplying the column with the specific gravity. We can convert it into water. Now we have reached this point. Now since we have moved by the same distance downward and upward in the same fluid, nothing to be right here, right? Now from this point, if we are moving upwards, we should subtract, and how much we are moving upwards? 0.08, And what is the specific gravity of this fluid? That is 0.7. Now from this to this, we are moving in the same green fluid, so nothing we should write. Now at this point, we are moving downwards, so we should add 0.06. Now in which fluid we are moving? We are moving in a fluid of a specific gravity 0.6. Now we have reached this point. Okay, so we are moving by the same distance in the same fluid, so nothing to write here. Now from this point we are moving upward, so we can subtract, and how much we are moving? 6 centimeter in the fluid of 0.9, and then we reaches atmospheric pressure. Then we reaches atmospheric pressure, right, my dear? Then we reaches atmospheric pressure, so we put it equal to 0, right? Now as we have placed it equal to 0, now if we calculate it, so I think we will be getting 0.022 meter, 0.022 meter of water. Are we getting this, or we are getting something else? Let's check once. Okay, let me check once. What are we getting? What are we getting? Can you tell me, beta? What are we getting? Can you tell me? What are we getting? So we are getting 0.022 meter of water. 0.022 meter of water. Are we getting that or not? Are we getting that or not? Right? Right? Okay, so as Keshav is telling me, just reconfirming it. All right, so we are getting 0.022. We are getting 0.022 meter of water. Now we want to have a change in pressure. So what we can do, we can multiply it with rho g. So g is given to be 10, and this is given to be 0.022. So 0.022 into 10 into 1000. So we'll be getting 220 Pascal. We'll be getting 220 Pascal. Now we remember, if we remember that from manometer, if we are doing this like this, and since we have placed 0 at the right hand side, and since we have placed 0, oh my god. So this is, so just 1 second. So HAW 0.05 minus 0.08. So we are, this is 0.8 now. Sorry, this is 0.08. This is 0.08 because we are moving to 8 centimeter. We are moving 6 centimeter upwards. So a slight change right here. This is 0.08. Okay, now you can cross check. Okay, so we are getting this PA is equal to 220 Pascal. Now we understand that from the manometers, the pressure that we get is gauge. Now what is asked in this question? Absolute pressure is asked, right? Absolute pressure is asked. So what is the absolute pressure? So we know the absolute pressure is atmospheric plus gauge pressure, right? Atmospheric plus gauge pressure. So what is the atmospheric pressure given in the question? So it is given as 100 Pascal, and the gauge pressure is 220 Pascal. So what is the answer? The answer is 320 Pascal, right, my dear? So the right answer is 320. Okay, so some of you might be okay. So it is asked in kilopascal. Actually, I have placed the answer in Pascal. So a slight mistake, we can ignore. We can ignore it, right, my dear? We can ignore it. Okay, so the answer to this question is 320 Pascal. Okay, right. So any doubt in this question? You may ask me. Any doubt in this question? Any doubt in this question? Please answer. Are we okay with this question? Yes or no? Very good. Very good. Now moving to the fourth one. Kedar, do you have any question? You have any doubt, my dear? All right. All right. So now in this question, what is asked? So we have these two pipes here. One is having water, another is having oil. Now, do we understand this? So we can see in this question, that the level of the column in both the limbs are same, right? So if I take it as xx, if I take it as xx, so we can see that the level of both the side is same. So we can say the pressure from the left limb and the pressure from the right limb both are same, right? Right, my dear. Now, if I see the pressure from the left limb, it should be the pressure exerted by oil plus pressure due to the column of oil. So what it is? Rho naught G H. Now on the right hand side where we have water, so let's say P of water plus rho of water plus GH into GH, right? Into GH. Yes or no? Into GH, right? Right, now we understand also that the density of water is greater than density of oil, right? It is given to be zero point 0.8, so we know the density of water is 1000 and density of oil will be 800. So what does that mean? Now what does that mean? That rho naught GH must be less than rho WGH, because G and H are same for both the cases. Now, this equality can only be maintained if P naught is greater than PW. Then only the level of the liquid will be, level of the column will be same. Yes or no? Yes or no? Now, to satisfy this equality, there is only one thing we can do, because we are most certain that rho naught GH is less than rho WGH. Now, this will only be maintained, this inequality will only be maintained if P naught is greater than PW. Say yes or no. Is it fine to everyone? So, what should be the answer? P naught is greater than PW. So, pressure in the oil pipe is more than the water pipe. Please answer me. Is there any doubt in this one? It's a good question. Please answer me. Do we have a doubt in this one? Do we have a doubt in this one? Please answer me. Any doubt in this particular question? I hope it is fine to everyone. I hope you have got the concept and all of you have given the right answer to this. Very, very good. Right. Okay. Now moving to this last question, my dear. Moving to this last question. Okay, Keshav. Moving to this last question. So what is the total pressure on the surface shown is? So now they are asking you total pressure. Now please do not have any confusion. So basically total force means what? Hydrostatic force. What do we mean by total force? So the meaning of total force is hydrostatic force, right? Right, because there is nothing like total pressure. So when we say total pressure, basically we mean integrated pressure. And what is integrated pressure? It is the hydrostatic force. It is the force on the surface, right? Right, my dear. So what is the hydrostatic force? So we know the formula of hydrostatic force. What is the formula? So the formula is rho g a x bar. Yes or no? Rho g a x bar. Right, beta? Right. So what is this rho? It is 1000. What is g? It is given to be 10. What is area? That is 6. And what is this x bar? So what is this x bar? So x bar is 5 plus 7 by 2. That is 6. Right. So if we calculate it, we'll be getting this much Newton. We'll be getting this much Newton. So how you can write it? So if you know one shortcut, yes, Keshav. So you are taught by me only. I know. So this is H1, H2. So X bar, if the top and the bottommost edges are given the distance from the free surface, so we can directly take the average of it to know the distance of centroid from the top surface. X bar is what? Distance of centroid from the top surface. So 360 into 10 to the power 3 Newton, that means 360 kilonewton. That means 360 kilonewton. So what is the answer to this question? The answer is 360 kilonewton. I hope you understood this also. Okay. Now this is all. So we have now seen the solution to the questions also. So I am hoping that you now understand. I am hoping now that you now understand. I am hoping you now understood. You now understood the concept well. Please tell me yes or no. Please tell me yes or no. So I hope you guys have liked the session. I am hoping that this you felt useful for you. So my dear, one last request, do not forget to like and subscribe the channel. Please share this to all your friends also, so that in the next session more students can join and we can have a more comparative. Okay. So in the next quiz, we will be having the questions from hydrostatic forces, buoyancy and kinematics. Right? Okay. So thank you all of you. Thank you very, very much. And I'm hoping to see you in the next session. Please do like, subscribe and share.